Hi guys, in this video we're going to look at the oxidation states of vanadium, the redox reactions of vanadium compounds, and then finally we're going to summarise.
So vanadium is a transition metal, and it has many of the characteristic properties we've learnt about in other videos on the transition metals and their characteristics. There are multiple oxidation states, for example, and vanadium has 4 of these, from V2+ to V5+. You need to know the colours for all of these vanadium species. So the first two are just vanadium on their own, so V2+ and V3+. So obviously that's their oxidation numbers as well. V2+ is purple, whereas V3+ is green. But then when we come on to the 4th and 5th oxidation state of vanadium, the most common ion that it's found in is attached to oxygen. So V4+ is found in VO2+. And this makes sense because oxygen almost always has an oxidation state of 2-. So if the vanadium has an oxidation state of 4+, that gives us the 2+ overall charge on the ion when we combine these two together. The same thing applies for the vanadium 5+, where it's found in a VO2 1+ molecule. Each of the oxygens has a 2- oxidation state, so that's 4- overall. The vanadium is 5+, and that leaves us with our 1+. These two ions are blue and yellow in solution respectively. All of the reactions we're going to study involving vanadium ions are solely redox reactions. We're going to take a closer look at these redox reactions for vanadium by considering the thermodynamic feasibility of the reduction involved in each step. We're going to use electrode potentials to consider this thermodynamic feasibility, and we have an individual video on the link between these two things, the electrode potentials and the feasibility, so we're going to be drawing on that heavily, and I recommend you go and watch it now if you haven't seen it before. So we can use the predictions made about thermodynamic feasibility to predict whether particular reactions are going to happen at all. So for example, if we had a solution that contained VO2+ ions, and remember that the vanadium in VO2+ has a 5+ oxidation state, we can consider how far these ions are going to be reduced when we add a reducing agent like zinc, and we're going to use an acidic solution of ammonia vanadate as the source of these VO2+ ions. So what we're going to do is compare the electrode potentials of each vanadium reduction to that.
Hey guys, to continue watching this video and unlock hundreds of other super concise exam board specific A-level chemistry videos, just click the snap revise smiley face here. Join me today, and together let's make A-level chemistry a walk in the park.